Calculate the gradient of the line joining the points A and B. Well, the gradient formula is m subscript AB, and it's y2 minus y1 over x2 minus x1. What we can do is label the points. X comes first, of course, y comes second. You have to be careful that you don't mix up the two and have x1 here and y2. That's very easily done, but is entirely wrong. So, subbing the numbers into the formula, 6 minus 3, 4 minus 2, minus is a plus, that gives a 9 on top and 2 on the bottom, 9 over 2. Example 2, I'm going to do the same thing as we did in example 1. We're going to calculate the gradient of the line joining the points C and D. Just for your benefit, I'll label these again. And then the calculation, 5 minus 5 over 4 minus 6. 5 minus 5 is 0. 4 minus 6 is 10. 0 divided by anything is 0. When the gradient is 0, it means that we have a horizontal line. Example 3, calculate the gradient of the line joining the points E and D. MED then. 4 take away minus 4 over 3 take away 3. 4 minus 4 is 8. 3 take away 3 is 0. Now we have to be careful here. 0 divided by 8 is in fact undefined. It does not equal 0, which is a common mistake. What does that mean? It means that the line joining the points E and D is a vertical line. And just to finish this one off, I suppose, if you look at the 2 points E and D, you'll see that they have the same x-coordinate, which is to say they have an x-coordinate of 3, and that is the equation of the line. Example 4, what we have is a diagram. We want to work out the equation, not the equation of the line, but the gradient of the line. So what we have to do, there are different ways of doing this. If you look at the diagram very carefully, you'll see that the line passes through this point here and this point here. Now, let's just consider, for every one box that we move along, we move 2 boxes up, 1 along and 2 up. The gradient can be found by using the very simple formula vertical change over horizontal change. So in this case the gradient is 2 over 1, which is 2. A gradient of 2 means that for every 1 box along we move 2 boxes up. Now there is another way of working with this. I'm just going to choose any 2 points on the line. We could choose this point here, and we'll choose this point here. You'll notice that the line is passing through those points exactly. Those are not approximations. So this point here has coordinates that looks like -2, -5. And this point here has coordinates 3 along, 5 up. So we can work out the gradient of the line. y2 minus y1 over x2 minus x1. I'm not going to write the formula down. So 5 minus 5 over 3 minus 2. 5 minus 5 is 5 plus 5, which is 10. 3 plus 2 is 5. 10 over 5 simplifies to 2, which is what we already had here. So the 2 calculations give us the same answer. Example 5, calculating the gradient of a straight line. We have the diagram here. What we have to be careful about is that there are different scales on the x and y axes. Now, on the x-axis, this is the x-axis here of course, and this is the y-axis. On the x-axis, one box equals 1. Now on the y-axis, we've got one box equaling 20. So that will make a difference then. Let me just pick 2 points. So here's a point here. And I could also take, I'll take this point here. This point has coordinates, so it's 9 boxes along, 1 for 1 on the x-axis, and it's 1 box up. So this here is 20. The point then has coordinates 9 along, 20 up. This one here, you can see it's 3 boxes back, so that will be minus 3 on the x. And where are we? Well, it's 120 on the y, so it's minus 3, 120. The gradient, very simple, y2 minus y1 over x2 minus x1. So 120 minus 20 over minus 3 minus 9. So that's 120 minus 20 is 100 over minus 12. Now, can't do much with that. You'll notice the negative is on the bottom, but generally, if we've only got one negative, it can sit at the halfway point. I can divide top and bottom by 4. 4 divides into 125 times, and 4 divides into 12 3 times. Slightly awkward, but there is the answer. The important thing then was how to deal with unusual scales.